We are going to learn about radicals. Before we learn about radicals, we need to see the perfect squares. This means to multiply a number by itself. So, 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5 equals 25, 6 times 6 equals 36, 7 times 7 equals 49, 8 times 8 equals 64, 9 times 9 equals 81, 10 times 10 equals 100, 11 times 11 equals 121, 12 times 12 equals 144, 13 times 13 equals 169, 14 times 14 equals 196, 15 times 15 equals 225, 16 times 16 equals 256, 17 times 17 equals 289, 18 times 18 equals 324, 19 times 19 equals 361, and 20 times 20 equals 400, and so on and so forth. We can do 21 times 21, 22 times 22, etc. But for this video, we'll only go up to 20 times 20. The square of a number means the result of a number that is times itself. For example, 4 is the square of 2, since 2 multiplied by 2, which is itself, is 4. 36 is the square of 6, since 6 multiplied by 6 is 36. 81 is the square of 9, since 9 multiplied by itself equals 9. 324 is the square of 18, since 18 multiplied by 18 is 324. However, the square root of a number is finding what number multiplied by itself equals that number. 2 is the square root of 4, since 2 times 2 equals 4. 6 is the square root of 36, since 6 times 6 equals 36. 9 is the square root of 81, since 9 times 9 equals 81. 18 is the square root of 324, since 18 times 18 equals 324. Now, let's do some problems. What is 12 squared? We mentioned in the last slide that 12 times 12 equals 144. Since the result of 12 multiplied by itself is 144, 144 is the answer. What is the square root of 25? We mentioned in the last slide that 5 times 5 equals 25. Since 5 is multiplied by itself to get the answer 25, 5 is the square root of 25. Now, let's try a problem that isn't as straightforward. What is the square root of 50? There are two main ways we can do this problem, where one way is used more than another way. I will show both ways in this problem and you can identify which one you like better. Either way you do it, you will get the same answer. The first way is to write 50 and draw a line to the left of it. Then write only the prime numbers that are factors of 50. Prime numbers include 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, etc. So 2 is a prime number that is a factor of 50, so I will write 2 on the left side of the line. Then I do 50 divided by 2, which equals 25. Now, which prime number is a factor of 25? 5 is a factor of 25, so I'll put 5 on the left side of the line. Then, 25 divided by 5 is 5. Now, which prime number is a factor of 5? 5 is a factor of 5. Then, I will put 5 on the left side of this line. 5 divided by 5 is 1, so I will put 1 at the bottom. You want to keep doing this prime factorization until you have 1 at the bottom. Now, I have a 2, 5, and 5 on the left side. Remember, to square a number, you need to have two of the same number. 7 times 7 is 49. 12 times 12 is 144. 15 times 15 is 225, and etc. So I will look if I have duplicates of the same number. And we, in fact, do have duplicates of the same number. We have two 5s. So I will group these 5s together. If we have a duplicate of a number, we will leave that number outside of the radical. However, if we do not have a duplicate of that number, we will keep that number inside the radical. Therefore, we keep 5 outside of the radical since we have two 5s, and we keep 2 inside the radical since we do not have another 2. Therefore, our answer is 5 radical 2. If you found that way confusing, let's do it another way with the same problem. This is the more common way, which is called the tree method. So we have the square root of 50. Now we are going to split it such that one of these tree branches are a perfect square. So I can split radical 50 to radical 25 and radical 2. You can double check because radical 25 times radical 2 is radical 50. Now we have radical 25 and radical 2. The next step is to split the perfect square, which in this case is radical 25. Radical 25 can be rewritten as 5. You stop breaking it down until there's nothing you can break it down to. In this case, you cannot break 5 or radical 2 down even further. Then we look at the lowest branches. The lowest branches are 5 and radical 2. This means that 5 times radical 2 is our answer. Therefore, our answer is 5 radical 2. This was the same answer we got the first way. Let's try another problem. What is the square root of 124? Let's do both ways to solve the problem. For the first way, we have 124 and we keep a line to the left side. Then we see which prime factors go into 124. 2 is a prime factor of 124, so we write 2 on the left side of the line. 124 divided by 2 is 62. Then, we see which prime factors go into 62. 2 is a prime factor of 62, so we write 2 on the left side of the line. 62 divided by 2 is 31. Then, we see which prime factors go into 31. 31 is the only prime factor that goes into 31, so we write 31 on the left side of the line. 31 divided by 31 is 1. Now, we have 2, 2, and 31 on the left side. Let's look to see if we have any duplicates of the same number. And yes, we do. We have 2 2's. So we will group these 2's together. Remember that if we have a duplicate of a number, we leave that number outside of the radical. Therefore, we keep 2 outside of the radical. 2 doesn't need a radical. However, if we do not have a duplicate of that number, we keep that number inside the radical. Therefore, 31 goes inside the radical. Our answer is 2 radical 31. Let's do the tree method for this problem. The square root of 124 can be broken down into the square root of 62 and the square root of 2. You cannot break the square root of 2 down any further, so let's look at the square root of 62. You can break the square root of 62 into square root of 31 and square root of 2. Now, we can't break it down any further. We can't break radical 31 down or radical 2 down. This is equal to radical 31 times radical 2 times radical 2. Radical 2 times radical 2 equals 2. Therefore, our answer is 2 radical 31, which is the same as our previous answer. We can even check our work. Since squaring a number means multiplying a number by itself, we multiply 2 root 31 times 2 root 31. 2 times 2 is 4, and root 31 times root 31 equals 31. 4 times 31 is 124. 124 matches what we had in the problem, so our answer is correct. Let's try another problem. What is the square root of 173? For the first way to solve the problem, we have 173 and we keep a line to the left side. Then we see which prime factors go into 173. These are some of the many prime factors. 2 doesn't go into 173. 3 doesn't go into 173. 5 doesn't go into 173. 7 doesn't go into 173. 11 doesn't go. 13 doesn't go. 17 doesn't go. 19 doesn't go. What you'll notice is that no prime number goes to 173. That means that the square root of 173 equals the square root of 173. You can't simplify or break it down even further unless you use the calculator and input it, and it will give you a decimal. Other than that, there's no way to simplify it. Let's try the tree method. We have radical 173. We can't simplify radical 173 further. So that's it for the tree diagram. Remember, we stop doing the tree diagram when we can't simplify or when we can't break the radical down further. That means that radical 173 is our answer. We can check our work. Radical 173 times radical 173 is 173, which is what we had in the problem, so our answer is correct. Let's try another problem. What is the square root of 1611? For the first way to solve the problem, we have 1611 and we keep a line to the left side. Then we see which prime factors go into 1611. 2 doesn't go into 1611. However, 3 goes into 1611. So we write 3 on the left side of the line. Remember, a way to determine if a large number is divisible by 3 is to add up all the numbers and see if that number is divisible by 3. For 1611, 1 plus 6 plus 1 plus 1 equals 9, and 9 is divisible by 3. So, 1611 is divisible by 3. 1611 divided by 3 is 537. Then, we see which prime factors go into 537. 2 doesn't go into 537. However, 3 does go into 537. The components of 537 are 5, 3, and 7. 5 plus 3 plus 7 equals 15, and 15 is divisible by 3. Therefore, 537 is divisible by 3. We write 3 on the left side of the line. 537 divided by 3 is 179. Then, we see which prime factors go into 179. 2 doesn't go into 179. 3 doesn't go into 179. 5 doesn't go, 7 doesn't go, 11 doesn't go, 13 doesn't go, 17 doesn't go. You'll notice that the only prime number that goes into 179 is 179. So we write 179 on the left line. 179 divided by 179 is 1. So we have 3, 3, and 179 on the left side. Now, we look for repeats or for duplicates. We have 2 3s, so we will group these 3s together. The 3 goes outside the radical, and since 179 doesn't have any duplicates, 179 goes inside the radical. Therefore, our answer is 3 radical 179. Let's do the tree method for this problem. The square root of 1611 can be broken down into square root of 3 and square root of 537. We can't simplify the square root of 3 any further, so let's look at the square root of 537. The square root of 537 can be broken down further into square root of 3 and square root of 179. We cannot simplify the square root of 3 and the square root of 179 further. When looking at the lower branches, we get square root of 179 times square root of 3 times square root of 3. Square root of 3 multiplied by the square root of 3 equals 3, and 3 multiplied the square root of 179 is 3 radical 179, which is our answer. We can check our work. We will do 3 root 179 times 3 root 179. Three times 3 is 9, and root 179 and root 179 equals 179. 9 times 179 is 1,611, which was the same in our problem.